In this Desmos activity, you are going to see a series of screens where you're going to have a graph and an expression, an algebraic expression. So you're going to have 6 of these, okay? And I'm going to show you how I want you to do this with the first screen. Okay, so the instructions are to simplify the expression and graph the simplified expression. The two graphs should lay on top of each other. So pretty much what I'm having you do here is look at this algebraic expression and simplify it by combining like terms, and then write the simplified algebraic expression here. If you simplify correctly, the two graphs should lay on top of each other. Okay, they will be equivalent if you simplify correctly, so they should lay on top of each other. Okay, equivalent means equal. If they're going to be equal, they're going to have the same graph. They're going to look the same. And I made this activity primarily because if you simplify correctly here, it'll lay on top of each other, and you'll know right then and there, did I do this correctly or not? If it's not, if the graphs are not laying on top of each other, then you didn't do it correctly, and you need to try again. Okay. So to simplify an expression by combining like terms, okay, like terms are the terms in the algebraic expression that have matching variables. We talked about terms in class, and terms for an algebraic expression are the pieces that are being added or subtracted. Okay, so I'm highlighting the terms right now. The terms for this algebraic expression are 2x, 4x, 6, 3x, and 4. And like terms are going to be the terms that have matching variables. So the like terms here are 2x, 4x, and 3x. Those terms can be combined because they are like terms. Like terms can be combined. The other terms that we have that are like terms are 6 and 4. Those can be combined. Those are like terms. They have matching variables. I mean, they don't have variables at all. So would, I guess, combine them. We would consider them like terms because they have like the same variable. The absence of a variable would make it be kind of like they have the same variable. Okay. Hopefully that makes sense. Anyway, these ones, we're going to combine 2x, 4x, and 3x. Okay, 2x minus 4x, that's going to be negative 2x. Negative 2x plus 3x is going to be 1x, right? So you're just thinking 2x minus 4x. 2 minus 4 is negative 2, so it's negative 2x. And then negative 2x plus 3x, that's going to be negative 2 plus 3, which is positive 1, positive 1x, which we know is the same as x, right? And see, the graph is already showing up. But we're not done because we've got this 6 and 4 that we need to combine. Positive 6 minus 4 is positive 2. Okay, and my graphs are laying right on top of each other. If it's confusing for you and you can't see like, oh, well, I don't really know if they really are laying on top of each other or not, you can click this button and you can see the red graph, and then you can click it back and click on this button and it'll show you the blue graph. When I click this button, it'll show me the graph, or if I click it and it's like empty there, it means the graph is not showing up. Okay, so if I click it, the red graph shows up right on top of the blue graph. If I click the blue, if I get rid of the blue graph, and then if I put the blue graph back and then take away the red graph, then just the blue one will be there. These ones, they're laying on top of each other. I know that means I simplified this correctly, and I get my feedback right away. I simplified this correctly. I have the two graphs laying on top of each other. That's it, okay? So then you'd go to the next screen and do the same thing with this one. You would look at this one, you'd find where are the like terms, you'd combine the like terms, you would write the simplified expression here, and then they would lay on top of each other. And then you would continue through all of the screens like that and that would be it. You would be done with the activity once you get through all those screens.